Hi, everyone. Thanks so much for joining us this afternoon, and welcome to the next installment of SWEEP's webinar series on waste characterization and composition studies, what they are and how to use them. We're so excited to be back and to be kicking off SWEEP's 2022 webinar series with you all today. I'm Sam Yeoman, SWEEP's Sustainability Program Manager, and I'll be moderating the Q&A and our conversations during and after our speakers' presentations today. We welcome any and all questions that attendees might have, so please post any that come to mind by using the Q&A tab function, which should be located at the bottom of your screens. In a moment, I'm going to take a few minutes to introduce today's speakers, and then we'll get started. But first, as attendees continue to log on, we've got some poll questions for you all to help gauge how familiar everyone is with the subject matter at hand. So here you go. Please take a minute to respond now. Okay, well, let's take a look at the initial results. Seems like, let's see a little bit, give you a little bit more time. Well, it looks like a majority of you are either somewhat or very familiar with waste characterization and composition studies. And it looks like most of you have actually done one within the last year, which is great. And it seems like everyone believes that the greatest benefit that a comprehensive waste characterization study affords is benchmarking waste materials management program efficacy. This is great. I bet you'll walk away from today's webinar with even a bit more knowledge on the subject. So thanks to everyone for responding. Okay, so on to speaker introductions. We are thrilled to have Chaz Jordan as our main presenter today. Chaz is a senior consultant and project manager at Kessler Consulting, an innovative waste solutions consulting firm based out of Tampa, Florida. Chaz is also a valued SWEEP Standards Committee member and continues to be a tremendous help in the development of the SWEEP Plus standard, which is currently being piloted by several local governments and private waste management service providers around the country. Chaz has a broad overview of solid waste and public works knowledge with technical expertise in project and program management, solid waste operations, financial analysis, and sustainability and emergency management. Chaz has managed major projects, including community-wide collections and recycling transitions, multiple collection and processing procurements, zero waste plans, rate and financial studies, and national recycling improvement studies. Chaz is very knowledgeable in management techniques, zero waste principles, solid waste operations, and long-term planning. After Chaz's portion, we'll hear from SWEEP's fearless leader, president and founder of SWEEP, Rob Watson. Rob is better known as the founding father of LEED, the largest and fastest growing international green building rating system, and is a top leader in market transformation and developing environmental performance standards worldwide. Rob's leveraged the lessons learned from creating LEED in the early 90s to develop the SWEEP Solid Waste Excellence Performance Standard, a system of market transformation standards geared to move the waste industry towards a more sustainable future. And without further ado, Chaz, please go ahead and share your screen and take it away whenever you are ready.
Can everybody see the presentation before I get started? Beautiful. All right. Well, thanks everybody for being here today. As Sam already mentioned, my name is Chaz Jordan. I work with Kessler Consulting as a senior consultant, primarily in dealing with solid waste and solid waste management, not only in the Southeast, but throughout the United States. To get started, I just wanted to tell you a little bit about KCI. We're based here in Tampa, Florida, but we operate throughout the United States. We've been in existence for over 34 years, and we've become a leader in the industry in waste characterization and composition, mainly because of the amount of studies we've performed, over 150 in the last 34 years. We've also assisted in developing the ASTM standard for waste and recycling characterization, which we'll provide in the chat for you all to use and take home with you. That way you can see the generally accepted requirements for characterization that are set out by that organization. One of our big mantras is that all waste is local. And we're going to go into why that's applicable specifically to these studies here in a few minutes. But we've done these studies now in multiple areas of the country, all the way out to California, Arizona, north to Ohio and Maine. And what we found is that organizations here in Florida, just next to one another, are very different from one another in their ability to provide solid waste collection service, what types of materials they collect. And as such, each organization really has its own unique attributes to it. And because of that, we always say that you need to study what's in your community specifically. And that's why we say all waste is local. So the primary purpose of our presentation is to talk about characterization and why is that important? You see on here the famous adage, if you don't measure it, you can't manage it. This line is attributed to a number of folks, Lord Kelvin, Peter Drucker. I just think it's a great quote to talk about why characterization is important for solid waste management. Measurement is a vital part of the management process. Without it, without the use of measurement of specific metrics, you cannot accurately depict success from failure. And so what does that necessarily mean in solid waste? And if you think about it, we use metrics and measurements quite a bit. Most of us use diversion rates as a metric of success for recycling or waste diversion in multiple different areas. That's a metric of tonnage that is not going directly to your landfill, something that needs to be tracked and updated and reviewed. Another one is collection efficiency. Namely, whether stops are missed or whether routes are having trouble being completed by a certain time period, or whether a type of collection process is being implemented correctly. It's another metric that we use quite a bit. And then finally, landfill life expectancy. For those of you who are here who manage the disposal side of our business, you know, once we put that hole in the ground, it doesn't mean that we can keep piling on forever. Some point that landfill needs to close because of state requirements, federal requirements, or the design requirements that were put into it. All of those things require metrics to effectively gauge, plan, and manage for. So in terms of materials management here, and especially the requirements being set by SWEEP for the SWEEP standard, characterization is a vital first step in developing these metrics that go into your sustainable materials management program. So how can it help you manage? How can it help you in making decisions to effectively implement solid waste programming in your community? Characterization, or as we here at Casey, I prefer to call it composition studies, can help with each of these 6 vital parts of your solid waste management infrastructure. First, in terms of management planning, knowing the composition of your materials stream and how or when the stream is processed is vital to laying out the long-term plan for your solid waste agency. Using composition studies just in the past few years, we have assisted clients in determining whether they should invest in more ways to divert waste, say composting or organics processing facilities, yard waste processing facilities, C&D. These long-term, high-cost projects require years of financial and management planning to effectively implement. And they start with accurate data so that you can determine the appropriate amount of throughput that those facilities could potentially manage so that you size them appropriately and manage them appropriately so that they best and most effectively manage your material. When benchmarking a program's effectiveness, perhaps in this case, most appropriately as an example is a curbside recycling program, many folks are now utilizing education and outreach metrics, say clicks or impressions on their materials to determine the quality of the program. However, a composition study is much better at determining that program's effectiveness. It documents very assuredly what waste is being diverted and the quality of that recycling in the stream, which can then be measured over various months or years to come as programs change or mature. And that information then directly leads you to the ability to target appropriate educational materials or outreach to improve that program. Let's say you have an influx of glass into your curbside recycling stream and it was removed from that program, say 2 years ago. Perhaps it's time now for a new communication program to your residents, reminding them of that program change. Perhaps you've had a lot of new customers move into the community or move into the area that you're managing. Perhaps it's only in a particular area of town and there's a lot of new college students who like to use glass quite a bit, and we all know what that means. This data can then make your outreach more targeted. You could focus on that particular area or that segment of your socioeconomic group, or it could make it more effective in how you message and potentially less costly because you would not have to spend as much to do such a broader outreach approach. But that's not the only potential cost savings that could occur. Perhaps let's just use glass again as an example. There's a similar community with glass as an accepted material, and they do a composition study and find that it's, say, less than 3% of their recycling stream. They may find that through an analysis of the removal of that stream or a reduction of how they process it through that stream, that they may have a return in the amount of processing fees they receive from their processing vendor. And that revenue sharing may be benefited by that by removing that material. And all it impacts is 3% of your stream. But you would know where people are typically disposing of glass, where they're putting it into their recycling, and where you would need to communicate that change, as well as how it would impact the stream at large. In terms of state and federal reporting requirements, the EPA and some states like here in Florida are now requiring, or they require, but they're really requesting heavily, regular reporting on solid waste metrics more and more to guide overarching environmental policy. A crucial part of this data in many respects is composition, as in how much of your material is a divertible waste and how much isn't, how much is going into your landfill and how much is going to other locations. Finally, programs such as the SWEEP standard are requiring regular studies to verify that you as an agency know what is going through your solid waste system to benefit your agency in all the ways previously mentioned. So there are a number of different studies out there, and it's good to know that a good portion of the participants on this call are fairly aware of what waste composition studies are. So I'm going to talk a little bit about waste comps, but also other types of studies as well that are all a part of the characterization bubble that could benefit you and your organization, and all apply to different types of metrics in building your sustainable materials management plan. Characterization comes in many different shapes and sizes. It's not merely a straight waste composition sort done near a landfill or transfer station, which it sounds like many of you are very familiar with. These terms on this slide have all just been developed in the past few years by our firm, just in developing appropriate scopes for customers' needs in terms of their data requirements. Many of them have been used by national partners. Say the Recycling Partnership is a great example to assist them in developing a national recycling strategy. But I'm going to go into more detail about each of them to give you some information on what each is designed to tell you in the end and how they differ in their implementation. And perhaps you could find benefit in using one of these to document and review the effectiveness of a program you're implementing. All of these studies incorporate an in-the-field program that then finalizes in a manual sorting of materials into appropriate categories by weight, as per the ASTM standard we discussed earlier. And you can see that here by the workers in this photo. These materials are separated and then weighed out versus the total weight of the sample to determine a percentage. And through the sorting of many samples, depends on the size of the organization, but we usually aim for 30 to 50, a study becomes statistically accurate to the entirety of the waste stream. So the one that probably everyone on this call is most familiar with is a waste composition study. Waste composition studies are studies done of inbound solid waste, which is usually termed class 1 or a municipal solid waste or whatever your term may be in your organization. But these studies review the total tonnage of material collected by an agency over the course of, we aim for at least 12 months. And then over the course of 1 to 2 weeks, we pull samples collected from across that stream's input sectors and then sort it. Per ASTM, a sample should weigh no less than 150 pounds for an accurate data point. So in a community that's quite large, we may pick 30 to 40 samples that we would try to geographically or by the amount of generation from those sectors pick to strategically and statistically accurately meet as many different areas of that community as possible. But each sample, once we pull it from there, has to be a minimum of 150 pounds. Typically, waste composition studies are used by landfill operating organizations or public sector clients to determine what materials could be diverted out of this primary stream. Samples are usually categorized by major material type and then more specifically focused into categories. So here on the slide, you see recyclable materials, you see textiles, household hazardous waste, many others. But they are typically more focused into categories within these larger groups, such as aluminum cans for recyclable materials or corrugated cardboard, or organic waste can be more focused on yard waste versus food waste versus other organics. And they focus on not only recyclable material that's being thrown away, but organic waste and other waste that could be diverted, such as construction and demolition debris, organics like we talked earlier, and other areas that are focused on what is all going into the stream and what are opportunities for us to remove items from it to lower the amount of material needing to be landfilled. Electronics and household hazardous waste materials specifically are important to know in terms of remediation requirements for landfills, as well as whether you need drop-off centers or collection options for customers so that you aren't putting that into the earth. For larger material streams like C&D and electronics, we typically also look at a visual audit option, and that's done on materials that aren't always able to be appropriately measured by weight. So one piece of concrete could be over that 150-pound limit. And it makes it very difficult for a team to go out and accurately measure a large material sample of that if that entire sample could be one piece of concrete. So we use studies that utilize volumetric data, as in how much space does this material take up, and generally accepted bulk density information provided by, say, EPA or Cal Recycle. And these determine potential diversion of these large waste streams that are not always as accurate as a weight-based directed sort like we would use for a class 1 material. The second type of sort I wanted to talk about is recycling composition studies, which are probably the most prevalent study that we see in the field right now, because they're utilized quite a bit for continuing to determine market value for processing contracts, and we'll get into what that means in a minute. In these studies, we perform a similar exercise as a waste composition sort, but specifically for curbside collected recycling programs. This could be a single stream, dual stream, curb sort program, whichever may be in effect. And there are two ways that we can perform them. The first is a pre-processing study, which specifically looks at inbound materials. So as I'm sure most of you are aware, recycling when collected curbside is then usually sent to a processing facility called a material recovery facility, or MRF. and they're sorted into various commodities for market. Many folks would like to argue that that process alone, that sorting through that MRF, should qualify as an inbound recycling study. But in our field, we have found that there is a difference between inbound studies done before they reach that point and the material sorting categories once it's done. And that's usually because there's various different ways that MRF operators and collection vendors actually process that material and different methodologies that they use. So we prefer to look at the material as it comes from the source, as in what is the material composition of the collector, not necessarily how it was processed. So we do a lot of pre-processing sorts that should specifically focus for community on what that agreed market value should be in terms of potential revenue sharing from the processor and what they're actually bringing into that processing facility. These sorts also provide the collector a great deal of information as well on the materials most of their customers are recycling, why, and what they may not be recycling correctly, which is all great information when improving a recycling program curbside. Now, that being said, we do perform post-processing sorts as well for the exact reason I just mentioned. And these are for agencies typically who would like to improve the sorting processes at their facility, as well as for, say, an owner, a county that owns a MRF, but contracts out the operation of it to a vendor to verify their effectiveness. We would look at what is the composition of that residue that comes out the other end, and could it be more effective in how they're actually sorting material through the program. Recycling as a system has many different customers, clients, and agencies, as everybody on this call I'm sure knows. Recycling composition sorts can then be used for various different parties in that supply chain. So for pre-processing sorts, we may work with a municipality or the public at large, and a county that's looking at doing recycling at a countywide basis. All of these parties may go into a pre-processing sort and are typically for local governments or for collection agencies to determine what they're doing well and what they could improve upon. Specifically in terms of contamination, whether they can educate better or collect in a different method so that they can get better quality material to a processor. For post-processing, these sorts are great for the effective operation of that material facility specifically. And when done correctly and looking at better improving means and methods at a location such as that, it would improve the market of those commodities as well, because you would see more material and cleaner material actually being provided for a specific material stream. So the next few are all studies that we've been working on over the last couple of years that are kind of new to the industry, but all fall under the characterization umbrella. A capture study is very interesting, and it's a newer type of characterization study that we've been performing here for a number of years. And it's becoming more and more requested by clients, basically because of the ability to look at material from multiple angles and sources, and is one that could greatly impact the characterization scene, especially for your group. So a capture study is basically a consolidation of a RCS and a WCS, a recycling and a waste composition study, but with a focus being on what recyclables are still in the waste stream and what recyclables or what waste is still is being sent into the recycling stream or contamination. So that capture study then uses the same data that we've typically done very straight line for characterization or composition over a group overall, but this actually reviews them against one another to say, okay, what are the materials that people still don't know they should recycle or should divert in a different way? And what materials are they thinking they can recycle and they shouldn't be? This study provides data on what types of materials should be in each stream, and it helps your community further assess recycling outreach and education, as well as the methodology for the collection. Maybe there's confusion at the curb that could be implemented in a different way. It looks at impacts of behavioral changes, effectiveness of collection services, and if issues are geographically or socioeconomically related, which is important when trying to look at things from a large community perspective, say a county or a very large city. These studies are probably best for determining recycling program effectiveness because they look at both sides of the problem. They are also targeted and are very good sources for data for determining the effectiveness of a pilot program. So this is the type of study we would implement for, say, a community that wants to implement a new multifamily recycling program or wants to consider conversion to curbside recycling, either at a single stream level or dual stream level. These are the types of pre and post data that we would incorporate to determine whether that pilot program is going to be effective. Capture studies recently have been used to determine the effectiveness of new diversion programs, such as multifamily recycling interventions, like we've done work with new bins in each actual unit. We've done a program where we've looked at larger scale recycling for the entire complex and what does that look like. And we've done these types of studies before and after to really give us an idea of their effectiveness. We've also done them for curbside single stream recycling program implementations and physical or educational intervention programs as well. A generation and capture study is basically a further iteration of a capture study, but it also takes the data received and estimates potential generation rates, which is a part of the sweep requirement for this area, using data on the customers included in the study. So this study uses customer count data provided by the community and develops generation rate estimates for all of the types of customers included in that study. They can be calculated for overall waste or recycling streams or even individual material types. This data is typically, this types of study is used to estimate the effectiveness over a larger segment of the stream. So the one we've been utilizing this most for and may be useful to you is multifamily customers. Typically multifamily customers are collected either through a residential system or a commercial system and are hard to segregate and really focus generation rates on just those types of customers. There's a number of communities that have done that and have done that very effectively, but many, it's hard to do that without substantial cost implications. So because of that, we look at things from a micro level and look at it in terms of the macro impact to give an idea of what the generation could be for multifamily on a larger scale. Source studies are very interesting because they can be applied to any of the previous 4 types that we discussed, but it includes a specific collection exercise where particular samples are retrieved from units, customers, or locations as designated by the client in the field. So KCI has performed source studies with single family residents and multifamily properties by gathering trash and recycling that has been set out for collection and use that data to develop capture information, composition rates across a community or a specific group of properties. So in this picture, you can see that our staff is at the curb collecting from a customer's garbage and will later be doing the recycling, which we gather together and in groups based upon geographic areas. This further reduced the potential of contamination inadvertently by the collection agency. Say it's a rainy day and they have the top open in the truck, that could potentially contaminate your material. Well, in this study, you get the quality of the material from the curb, and you can determine based upon a larger composition study of the collection what the differences are. Maybe the collection agency needs to work on their handling of material better, and maybe that will improve your contamination rate. Well, you won't know that until you know what's coming from the curb itself, and that's where these kinds of studies step in. These studies, though, do require a significant amount of field work. So on top of that basic composition sort, they are typically hard to develop appropriate protocols for and typically take a little bit more time to implement. So in looking at the nuts and bolts of a composition study, one of the larger aspects of it is study generators or sectors. And this is a big part of developing the characterization protocol at the get-go. and what you really want out of a characterization study if you choose to implement one. These are dependent wholly on the customer. They can target particular collection rate types, so residential or commercial. You usually have a residential solid waste rate or commercial solid waste rate. So you typically want to know the generators based upon those. Or they can be across institutions. Maybe it's a school district that wants to review all of the schools in the district. We've even performed a study as specific from a private vendor on the floors of a building. So first floor was this, second floor was this, and I believe is actually split in half as well by one side of the building versus the other. We are currently finishing a composition study for a county here in Florida that looks at all of the cities in the county as well as its incorporated area, as well as an aggregation of those findings. And what this does is it helps them determine not only which of their municipal partners could use extra support and the quality of their recycling program and diverted materials, but where they can more appropriately target funding, communications, and so on, so that they know where to improve their system. Generators could be anything. It could be a region, could be specific complexes in a particular facility, could be larger areas. It could be anything that would assist the organization in determining where focus is needed for the future. It could be looking at various types of properties. It could be looking at geographic areas. There's no limit to what these sectors could look at, other than the ability for us to effectively sample them. So this is a vital part of the protocol development of a composition study, whether it's waste, recycling, capture, any of those, is determining what we really want to get data from so that we can effectively communicate the results to you. So this is a basic table of a conglomeration of 5 recent studies that we've performed here at KCI, just to give you an idea of how we would provide you data from one of these sorts, and how they vary from one location to another. I think the first thing you'll probably notice is that they're fairly similar. Most of them are have a close percentage in fiber, containers, materials, and contaminants, but they aren't exactly alike. And that's really the important part here, is that they can change based upon a number of different factors. While we agree there are definitely similarities here, we go back to that mantra of all waste is local, and why characterization studies are vital to effectively managing your program. As you can see in this data alone, while these studies are all in the same state, they have very different containers numbers. They also have we have one that very specifically has a large amount of corrugated cardboard. These areas alone can greatly impact the revenue that those communities receive when working with a processor to source recycling. Just by reviewing this data, I can make some very quick assumptions just based upon these percentages, like the fact that the second community here with the 50 samples at the top has a significant amount of cardboard being recycled, either wet or recyclable. And this is probably due to the community having some way of segregating and bringing in cardboard materials, probably with cardboard recycling dumpsters or something as a part of their overarching recycling program, leading to that percentage of their stream being much higher. I can also see a correlation to the amount of grit that is being studied here and the amount of glass. So as you all know, glass being broken down into smaller bits eventually becomes grit. And the more glass in your stream, the more likelihood you'll have more grit. This is just a very basic review of findings that this data provides us immediately. But coupled with specific sample data, say from those sectors or geographic areas, you can then determine much more specific items for potential correction or improvement, or areas of quality. Maybe you want to emulate the fact that there's so much OCC in this stream in this community. That's a good thing from a revenue perspective. And from an overarching diversion perspective, it is. So maybe we want to continue that process. So we would look at where are the larger percentages and see what's working effectively in those areas. This is a basic representation of the results of a recent RCS that we performed, and is an example of a fairly effective single stream recycling program currently post-COVID, with all of the fun things that have happened lately. Contamination here is just under 20%. That would be the gray and the orange bars that are on here. As you can see, materials are broken down into categories agreed upon in the protocol for the sort. And based upon an average of the weights for each of these categories over the samples collected, we come up with a set of results that are similar to this and the table that's on the previous slide. This data can then be applied to, say, recycling markets data on current value of commodities and priced per ton to develop an accepted market value for a ton of your recyclable material with your processing vendor. But it also tells you where you're doing very well. Obviously, people are recycling glass, paper, and cardboard in this community. So those are things that, people already understand and are doing well, but they're not necessarily recycling PET bottles or aluminum cans as much as some other communities. So maybe this community needs to focus on those areas for continued improvement. The sweep requirements are listed here to give you an idea of where this applies specifically to the sweep standard. And the sweep standard has been set to really give a direction to communities on how to best implement their sustainable materials management plan, and to give you credit towards that in that section of the standard. As listed here on the side, you can see that agencies considering this program need to have a policy and a procedure in place to regularly conduct, at minimum, a characterization study or a generation study, which again does not need to be done by a consultant. It could be done in-house. This provides base data for developing your plan and how to appropriately target potential waste for reuse, recycling, or processing to limit landfilling and to extend material life cycles, which is really the focus of the majority of the standard, and developing good ways to continue to improve your materials management program. Studies are important, namely because of what we've already discussed. Each community is different, and you have diverse demographic collection and processing factors that provide you non-standardized information. There are a number of groups out there that provide tabletop and data-driven exercises which have their value, but they're difficult to apply directly to your organization in some ways. There's also varying reporting practices. So if an organization in Arizona or California has a specific reporting practice that's different than the one here in Florida, it's good to set up a protocol that follows that process. There are some inconsistent definitions and methodologies out there. However, we recommend following the ASTM standard as the baseline and building upon that in ways that you can most effectively implement the requirements that are set in there. And finally, there's numerous local factors that impact characterization, including things like COVID. We saw over the course of the studies that we performed, once we were back to performing them after COVID, a great increase in residential generation and a great increase in OCC rates because of use of online shopping and a number of other things that were directly correlated with shutdowns due to COVID. Those factors are hard to qualify without doing studies at that time. And those are things that can help you in determining ways to change and ebb and flow while things are changing around you. So finally, what does a study provide? It provides you real actionable data. It provides you information that you can actually work with to improve and build upon your program. It gives you benchmarking and reporting data that will help you in improving that going forward. And you can evaluate your programs based upon it. You can actually mark success in a lower diversion rate, a lower contamination rate, greater generation rates, and so on. It'll help you identify future diversion opportunities. Maybe your waste characterization shows that we see in most places around 20% food waste. Well, that may be a diversion opportunity to research and how would we process that and get that out of the stream. It helps you to focus your outreach. It would help you with certification programs like here with the sweep standard. And again, as with anything with solid waste, the more you remove things from our landfill, divert and develop good practices there, you have a positive environmental impact. I'll close with one accurate measurement is worth 1,000 expert opinions. And in my own expert opinion, I always rather have as much measurement data as I could have to determine how to opine how I'm going to move forward in a management role, especially in solid waste, because it's over the course of years and decades that we make positive changes in this industry, and it starts with good data. So with that, are there any questions or thoughts? And Sam, I will stop sharing at this time.
Awesome. Thanks so much for that, Chaz. Super interesting. We do have a couple of questions while Rob gets his slides set up. First question is, have you done litter audits too, and would they be organized as a composition study, or how would those be conducted differently?
We've done litter and waste audits at the curb. Those are done a little bit differently because they're similar to the waste audits I mentioned during waste characterization studies, just because of the amount of material is really minimal. So you're really doing more of a visual audit of the volume of material you're collecting. We've done that very briefly for a few communities, and the data pretty much shows that people typically are littering the same basic things, cigarette butts and so on and so forth. But from an overall solid waste management perspective, it's hard to give a real value to that data. We would recommend that you do something more along the lines of a larger composition study to really look at what's going into the stream, and then review that maybe based upon some litter audits to determine what's not making it into people's cans.
And just an advertisement, which we'll get to again, but we will be having a litter focused webinar later this month.
Absolutely. Let's do one more question and then we'll move on to Rob's portion. What are your thoughts on a desktop waste composition study? Do you think they are accurate?
I think desktop waste composition studies, depending on where the data is coming from, can be very valuable. They're definitely a little bit more affordable because they don't require the labor that is necessary. However, it's again based upon where the data is coming from. As I said earlier, with our mantra, all waste is local, we prefer to get data from your community, and desktop studies typically take it from other communities of similar nature to really estimate waste composition, because that's usually the only place that you can really apply those data sets to your overall tonnage. So it depends on where they're getting that data from, how they're developing their model. Some of them are very, very good. I think I've seen quite a few that have done very, very interesting stuff with that type of system. But again, it's still an estimate based upon other people's data. So take of that how you will.
Great. I think that does it for now, but we already have a handful of other questions for you that I'll ask you at the end of Rob's portion. Looks like Rob's got his slides ready to go. So Rob, whenever you're ready, take it away.
Yeah, we have a couple folks raising their hands, and the best way to get a question answered is to put it in the Q&A tab, and then we will make sure that we get all the questions answered by the end of the presentation. So I'm gonna, I have nothing to add really to Chaz's excellent presentation, but I will talk a little bit about some of the things that as a consumer of waste characterization studies that we have found, and then give a very brief overview of what SWEEP is for those of you who have not joined us in previous webinars, and then we'll go back to the Q&A. So, one of the biggest problems with measuring waste is how much is there, right? You talk to EPA, they'll tell you there's around 290, 300 million tons. If you look at the work that Waste Business Journal, Biocycle, EREF, Yale have done, they're all within 10% of 450 million tons. And one is a modeling exercise by EPA, whereas the others have actually called up facilities and said, how many tons are you doing? So, obviously, as Chaz has mentioned, getting your hands dirty and into the waste is the best way to understand what's there. And from a macro policy perspective, you can't solve a 450 million ton problem with a 290 million ton solution. So one of the things that SWEEP is trying to do is to get some regularity in reporting of waste generation, reporting of characteristics of both mixed waste and recycling. But obviously, in spite of the tremendous industry expertise out there, waste characterization studies or waste composition studies are expensive. They give you tiny snippets of a movie. You're trying to do a year-long movie, and you're only able to do a week or two per season if you're lucky. So, the ability to figure out what's going on an ongoing basis will be very helpful to understanding how your programs are performing and also how to design your programs. I'm going to reprise something that Chaz said earlier and add to it. We attribute can't manage what you don't measure to Peter Drucker. But one of the big challenges that we have currently in the industry is that we haven't defined things, either define them mostly consistently, and sometimes we haven't defined them at all. So one of the key things is that SWEEP is looking to do is provide a consistent set of definitions. Standards like the ASTM D5231 are super helpful for that. And you'll notice that if you read SWEEP, that standard is not referenced. And so one of the processes that you learn as you go through things like piloting, et cetera, is what's missing. So clearly, based on this and other input from our members and pilot participants, we will be improving the standard and ensuring that we have a framework. Our job is not to reinvent the wheel. Our job is to take what's working really well, maybe tweak it a little bit, but to start with a series of definitions and a series of calculations that are pretty close to what's going on, and then over time, as we get better at it, move it in a new direction and break new ground. So just as an example, I've looked at waste characterization studies for probably 50 jurisdictions. And I just picked 4 random ones, and spent 30 minutes going through them, looking at the general categories, and then the specific categories within plastics. This is not intended to be a scientific or comprehensive study, but merely an illustration of the challenges that one faces when one is trying to understand what's actually being thrown away and how it's characterized. In the general categories, there's a reasonable amount of agreement. There's paper, plastic, glass, metal, but then the organics get a little bit dicey. Is it food? Is it yard? Is it other? What's an insert? What's special waste? What's mixed residue? Right? A lot of these things don't have definitions, and as you'll find, sometimes these mixed residue numbers can be in the 25 to 30% of the waste. That's almost a third of your materials that you have no idea what it is, right? And the other big challenge is that the vast majority of waste characterizations are focused on residential waste, and yet commercial waste, obviously, it's backed off its importance in the last couple of years, but probably will come back. Commercial waste is more than half of the waste stream in many jurisdictions, and if you look nationally, it could be up to 2/3 in certain areas. So there's a lot of material that we have no idea what it is, and that's where modeling can be very helpful. The waste characterization from EPA is a great place to start, but again, between jurisdictions you can find a fair amount of variation. But as you and ideally, what you would do when you're solving a problem is thinking of it as a fractal. And a fractal is basically a pattern that repeats itself. So if you start at 1 and you go to 10, the pattern at 1 is basically the same pattern at 10, same pattern at 100, et cetera. But what you find is that when you drill in to the specifics of each of the general categories, you find a much more diverse set of definitions. So you get plastic 1 and 2. What does that mean to a waste sorter? What does that mean to a consumer? Basically nothing, but it's really important for a manufacturer to know what kind of waste, whether it's plastic 1 or 2. You can get a red, detergent bottle that's HDPE. You can get one that's polypropylene, right? And a sorter might say red plastic. Okay, good. Is it recyclable? Well, if it's number 2, yeah, pretty much everywhere. If it's number 5, not so much, right? And obviously, if a manufacturer gets a number 5 instead of a number 2, that can mess up their extrusion and pelletizing and sale. So being able to distinguish at a much finer level will be really important. So one of the things that's really exciting is some of the Holy Grail stuff coming out of Europe, where basically materials are going to have a digital watermark on them, so those might be able to be scanned with handheld things, which will strongly facilitate waste characterizations, enable things to be measured and characterized at the MRF level. So there are a lot of really interesting opportunities, and particularly with blockchain, where you can distinguish small units of measurement and aggregate them will also be very important. But having consistent material characterizations, not only for the people that are handling the waste, but ultimately for the people who are receiving it, is really important. Is one of the things that we're trying to work on, aggressively at Sweep. So the other big challenge is deciding what is diverted and what goes into a diversion count, right? And that has to do with the nature of the material, what happens to it, where it comes from, right? So if you have a consistent methodology, you can have dramatic differences between what is reported using sort of, if you will, a gerrymandered boundary of your study and characterization versus one that's consistent between jurisdictions. So you can see, places like King County, have a fairly good consistency between what's reported and what's calculated using a consistent methodology. But when that same methodology is applied to San Francisco, fully a third of the diversion rate goes away. And so this can be, a lot of people are sort of like, oh, our programs are so bad and San Francisco is so good. And let's be clear, San Francisco on a national basis is a leader, but it's not an 80% leader. It's a 50% leader. And that's 50% better than 30%, national average, but it's not, 2.5 times the national average, right? So understanding, where you are and how effective your programs, really depends on how you define your boundaries for, what counts as diversion. The reason San Francisco's number is so big is that they move a lot of dirt for construction. And so if you dig dirt out of one hole and put it in another hole, hey, we've recycled those giant tons of materials. And so it can really distort the calculation. Other people aren't giving themselves enough credit, like Minneapolis. There are some things that they're doing that would be considered diversion under certain situations, and some things that are not. So getting a consistent set of calculations and frameworks is what we're trying to do with Sweep. And just one more example within the same zero waste report. You had the generation calculation of about 2.2 million tons, of which 3% was characterized as metal. So simple calculation shows that about 66,000 tons of metal are generated. But then you go back into the report and you look at the white goods, the aluminum scrap, the cans, the ferrous metals, mixed metals, non-ferrous metals, steel and bimetallic cans, and all of a sudden you get literally 10 times the amount of metals recovered, maybe 9 times, because obviously not all the white goods, there's some plastic and white goods and stuff like that, but these are mostly metals, and all of a sudden you have 600,000. So what is it? Is it 600,000 tons, or is it 66,000 tons? And how can you do policy when you're dealing with 1 to 10x of vital materials such as metals? And so hopefully with a consistent set of boundaries, what's in, what's out, how things are characterized, we can get good, consistent policy, not only within a jurisdiction, but between them. Anyway, I've already said this, fixing the problem, no need to repeat that. So a little bit about SWEEP. We're, somewhat new kids on the block, even though we've been around, 6, 7, 8 years now. And our mission is to transform the materials management industry, not unlike what we did with LEED. And essentially, we're trying to provide, a simple benchmarking system and roadmap for future activities that provides third-party independent verification focused on people, planet, profit. So not just focusing on the diversion rate, which is vitally important, but what about all of the other great things that people are doing in terms of fuel switching for, their electric collection vehicles, or, natural gas vehicles, or biofuels, or, all the safety programs, the training programs that are so vitally important to the people. What about environmental justice? All these aspects of sustainable material. Again, if we look at sustainability from not just the environmental perspective, but also from the social perspective and the economic perspective, having a comprehensive view and a comprehensive standard like SWEEP is very important. So, taking a page from the LEED book, we're looking at the top quartile for SWEEP Plus, which is the first standard out of the box. We will be developing a lighthouse standard, SWEEP Zero, which will define zero waste, and then a mid-market standard called SWEEP that will get at the mid-market. And each of these will designed to fit together to allow a progression from SWEEP all the way to SWEEP Zero. If a community or an organization wants to do that, we want to be able to, if our job as SWEEP is to try and move the market train, having 3 engines instead of 1 will be much more powerful and much more transformative and much quicker, because we don't have as much time as we would like to think we do. Our focus is local governments and the material management companies that provide services. Those are the entities that not only are able to be members of SWEEP, but also get certified. Membership is open to all technology companies, consultants, NGOs. We welcome broad perspective in helping us establish the framework for sustainable materials management, whether it's at the zero waste level or at the let's work on improvement parts of it. So if you are a local government, whether you're a regional solid waste authority, whether you're a small city, a large city, we would love to welcome you into the SWEEP family and see if we can get you involved with the pilot program. And similarly, if you are handling waste in an integrated fashion from collection through disposal or recovery, or if you are a community composter, we can also look at your facilities and your activities and independently verify your performance through SWEEP. So just a very quick breakdown of SWEEP. We have 5 categories. The first 2 are focused on sort of paper, if you will. So making sure that the policies are in place, that the intent has been established, that your framework for gathering and analyzing data is consistent and established. And then we get into the physicality of the supply chain, where we're looking at collection, recovery, and disposal. Over time, we will move more points out of the paper aspects and into the performance aspects, but coming right out of the box, we don't want to judge people on a standard that they've never seen before. And getting that framework and establishing that foundation is super important. And then it's also important to note that we do not give any credit for disposing of material. Rather, if you're managing your landfill gas, if you have safety programs, if you've got alternative fuels in your large equipment, those are the kinds of things that we reward under this system. But obviously the diversion is something that we specifically reward. So we have a lot of good questions on deck. I'd love for Chaz to answer some of the questions that were put to him. And if there are any questions for me as well, happy to provide answers.
Great, thanks, Rob. So yeah, the first few questions are for Chaz. First one is, Miami just announced in a huge article in this week's Miami Herald article that they have a 49% contamination rate for curbside recyclables, up to 25% a few years ago, up from 25% a few years ago. Other cities are also experiencing record high contamination rates. What do you see happening?
That would be consistent with a number of the large cities that we've worked with in the last few years specifically. They have seen very large contamination rate increases over the last couple of years. It seems to be following with large communities, large cities and counties. We've worked with a number of communities or counties that has stayed very stagnant because they don't have a large central metropolis, but the cities themselves, for some reason, have seen a great increase. So I would say that's consistent with what we've been seeing.
Great.
And I think, there's wish cycling. This is plastic. It should be recycled. I think there is a bit of sabotage. I don't want to recycle this, so I'm going to put garbage in to express my disapproval. And I also think that the definition of contamination has expanded because after National Sword, at least for a while, what programs could handle effectively or cost effectively, like glass became a contaminant in several programs, and people were still recycling glass because glass has always been recyclable. But since there was no market for it and they couldn't get rid of it, it was one of the, there's been a sort of a change in the definition of what contamination is. So I think all three of those factors are at play.
Gotcha. When characterizing, how do you account for shifts in waste composition through the seasons? Seasonal characterization studies, or are seasonal composition changes mostly negligible?
No, we definitely do seasonal characterization studies. In fact, the recent waste comp that we performed, we typically recommend a 2-season study, and it's really based upon the weather and the different aspects of that community, whether there's a strong tourist season, whether there's a large campus on hand or anything like that. We'll consider those variables and always pick one study that would be during that primary season and one without, so that you could see shifts throughout the year in terms of your waste characterization. Because if you only do one, say in the middle of, say you're in New Orleans and you do it in February, March, where everybody's there for Mardi Gras, that's not representative of the remainder of the year. So we would recommend something probably not in those months, but close to it, and something that's far off from those months to really see what your characterization looks like from a year-long perspective, not and based upon those 2 seasons, not based upon just that one data point.
Awesome. Next question is, do you suggest using benchmarking for predicting what waste characterization would look like in 5 to 10 years? Or are there too many exogenous variables that would change the waste composition?
I would say the second part of that question is probably pretty accurate. I think the last 5 years is a great example of, you can benchmark, but the benchmarks could be off. Something can happen that could greatly alter your waste stream. And so benchmarking is a great way to guide your planning process, but we always recommend that you gather data on a regular basis to perfect and accurately portray those benchmarks for the quality of the planning to improve and for you to continue to manage effectively.
And because it's expensive, SWEEP is looking at trying to handle it from a regional perspective, so that if you're having a waste characterization, waste composition study at a landfill, for example, then everybody within the waste shed could theoretically benefit from that. So this might be a way where a number of small communities might band together, get a waste characterization study funded at the regional landfill, and then all of them benefit from that. So at least providing a little bit more visibility into it and without breaking the budget.
Gotcha. And the last one for Chaz is there a major disadvantage for conducting a recycling composition study through the use of a processor sorting equipment versus hand sorting?
And I answered that one on there, but I'll go ahead and respond on here as well. It depends on what you're trying to get out of the data. So we from Kessler's perspective, we typically recommend that you do a hand sort prior to that, because there are so many variables based upon the processor that come into play now once you go through the sorting system at their processing facility. So maybe their eddy current's not working correctly, or the magnets aren't pulling out the right metals, or whatever. That's not your fault from the provider of the materials perspective. Your materials are still your materials. So we typically recommend that you do that before that, so that it's based upon one standard system. They're being sorted, hand sorted into very specific categories, and then you can put all that through there, as opposed to when you go through the other system, you're adding the variable of their means and methods, which if that's okay with you, then by all means follow that process. If the value of the data is really to find out how you need to communicate to your residents or so on, that's fine. But for a processing contract, I typically don't want the person that I'm contracting with to determine how the revenue share is going to be developed. I'd rather that be done by somebody else. So that's just my 2 cents. I think there's quality in both, but we definitely recommend on our end that you do something before that. So you take all of those variables out. Those aren't your issues to deal with. Your issue is, what are you getting to them, and figure out what that is.
Awesome. Here's a question for Rob. How does SWEEP look at waste diversion methods that vary in acceptance, like ADC, incineration, and other forms of waste to energy?
Okay, so for SWEEP Plus, ADC is not counted as diversion. Incineration is not counted as diversion, and other forms of waste to energy are not considered diversion. We are looking at things that are kind of in the gray area, like what is variously characterized as gasification, advanced recycling, chemical recycling, et cetera. And a lot of it depends on what happens, right? If you gasify something and then you burn it as energy, that's basically waste to energy plus one step. If you're taking the gas and then turning it into monomers and polymers, that goes back into plastic, then that is recycling. So, as we build up our ability to trace things through the post-collection supply chain, we'll be able to differentiate. But right now, it's really hard to get that granular with what things are going. And so that will be an area that we will continually look at, and as the infrastructure builds up and we get more certainty about those processes, we'll have new answers for that under SWEEP Plus. And then under SWEEP, it may be that the consensus is that these are counted as diversion under SWEEP. So we can't know yet what the consensus process will deliver. Obviously, under SWEEP 0, there's nothing that would be going to a landfill that would be countable under that. Looks like we're getting kind of late, so I appreciate everybody's patience and everything like that. I wanted to give a shout out to the EPA portfolio manager, and that as an initial tool for finding definitions and looking at waste characterizations. And then there was also a question about what differentiates SWEEP from ASHI and Plan Zero Waste Atlas program. And those two are more facility oriented, whereas SWEEP is more looking at the policy and the system at the macro local government level. There may be some similarities or overlaps with the campus version of SWEEP, but our goal will be to coordinate with ASHI and Plan Zero as not to step on, but to complement and supplement existing standards.
Awesome. Yeah, that'll conclude the Q&A portion. Just a huge thank you to both Rob and Chaz for the super interesting presentations. For everybody that's still with us, if you'd like to access the recording of this webinar, or just want to stay up to date on future SWEEP webinar events, you can follow SWEEP on LinkedIn. visit our website, subscribe to the Sweep YouTube channel, or join our mailing list. To be added to the mailing list, just reach out to info.sweepstandard.org and we'll be sure to add you. Rob, if you could go to the next slide. So be sure to tune in for the next installation of Sweep's webinar series taking place on Wednesday, May 25th at 2 p.m. Eastern Time, focusing on battling litter and hazardous waste in the digital era with co-founder and CEO of Rubbish, Amin Israfil. Rubbish is a San Francisco-based tech company with a mission to create clean, safe, and healthy neighborhoods via innovative real-time data capture technology that maps and categorizes urban litter to evaluate a city's footprint, city block by city block, to identify better solutions for cleaner communities. Rubbish's work has been featured on Apple, Google, Accenture, and ABC News. Should be a good one, so be on the lookout for more details to come in the next couple weeks. And that's it for today's webinar, folks. Have a great rest of your week, everyone, and see you all next time. Bye for now.